Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in week number 62. Yep, we're in bonus episodes. This is probably bonus number 10. Maybe I should call them that. I don't know. Anyway, I just can't stop doing it. It's fun to write this code and then to talk about it. What are we talking about this time? We're talking about two things. One is summarizing the data, so doing hourly summaries of this response time and availability data and storing it in the database. And the other thing we're doing, as you can imagine, what happens to this data after we've accumulated it? Well, if we never get rid of it, then we may cause our entire system to crash or bad things to happen. So what if you wanted to trim data, like these graphs right here only show the last 24 entries? What if we got rid of that 24 hours later? And this is only per minute data. And so we also want to be trimming these tables. In addition, there's capture data, there's trace route data, there is port scan data, and that we get rid of much quicker than 24 hours. Anyway, we keep things pretty clean. That's the idea. We talk in this session about the fact that Quokka, when I implemented the very first Quokka, I implemented everything as individual threads. And so rather than having discrete autonomous applications running for monitoring of devices, hosts, and services, I had them within the actual Flask application. And I actually like the way that the Quokka Prime turned out a little bit better. And that's how we did it, mainly for teaching purposes. And it's just serendipitous that it turned out better. But I digress. Summaries, that was in here as well as trimming. And you know what? It kind of belongs in here. It's not going to be distributed in different networks across the domain or whatever. It actually needs to be living here with the database because these are database applications. So I'm using this old slide that shows SQL Alchemy. We're actually using Mongo. But just for your purposes of understanding, I'm going to be adding a thread to our application, and that will be running hourly, and it will do the summaries and trimming of old data. That's what we're going to talk about. Hopefully it makes sense. Let's get started. Okay, so let's begin to look into the two things that are the topics for this lesson. The first one being summaries, and the second one being trimming of old data. So here is a look at what we're talking about, just so you know where I came from. This is my services screen, the same thing that we've been looking at for a while. I did add this. We saw this last time that I added a button that I could get the time series data. And last time we showed just what you see over here on the right. Let's see if I can do that. We could see just that part. But now I've added this other part that you see over here on the right-hand side, which are the summaries. So what I'm doing, as you can see, is this is from like right now, which is a little bit before 9 o'clock, all the way back to probably the last 24 items. That's a half hour or so. Over here, however, you'll notice this is 3 p.m. That's yesterday. 3 p.m., 6 p.m., 9 p.m., Tuesday, that got to be today, 3 a.m., 6 a.m., etc. So these, and as you can see with the little dots here, this is where the measurements occurred at that particular time. You can see I'm doing these every hour. And you can see a big gap here. That's when Microsoft decided that it would be a good time to not crash, but I guess restart my entire Windows host and do updates or whatever the heck it was doing. So I missed a few hours in there. But you kind of get the idea of what's going on. I'm getting a new one of these every hour, and that is what we're calling the summaries. So the general idea is that I will take this data, and for an entire hour, which you only see 24 entries here, but this would be, since I'm monitoring every minute, that would be 60 of these. I'm going to gather up all 60 of them, and I'm going to average it over that an hour, and I'm going to create a data item and put it into a database table, the summaries. So that is what we're talking about with summaries. I've done this If you're familiar with the original Quokka, I didn't do this for devices because I had CPU and memory utilization, but I have done it here. So this is kind of an interesting graph of response time from CSR Sandbox. That's one of the Sandbox Cisco devices. Availability is looking pretty good, except that it went down for a while, you can see. And over time, you can see that on the hourly that the availability seems to bounce between 90 and almost 100%. So that's pretty good. Now the last thing I want to point out here is these yellow dotted or dashed lines, I guess you'd say. These are my service level agreement. So like the summaries and a lot of this functionality, I've imported that idea from the original Quokka, and you can define what the service level agreement is for a particular device, for a particular service, and we will draw this line on the graph. In the original Quokka, I generated events that would identify what has occurred if a service level violation. You see here availability went down below the prescribed SLA value, service level agreement value. I would generate an event. I'm not doing events in Quokka Prime, at least not yet. So that is what you see, and that is what has been implemented. And so we're going to talk about how I actually did that. So I described summaries there. I meant to describe trimming of data, but let me do that now. The basic idea is this. This data is coming in every minute for every service, for every host, for every device. Now, over a short period of time, a couple of weeks or whatever, that's not going to have a huge impact, but a real legitimate implementation would want to be getting rid of the older data, especially as we have it summarized here. So what I did also is I'm trimming away old data from these tables in the database. So I'm trimming not only status data, but also things like packet captures, that once you've looked at a packet capture, once you've done a packet capture and looked at it, you probably don't need to keep it around forever. So I've arbitrarily decided for status data that I get rid of it after 24 hours. For what I call diagnostic data, which would be packet capture or trace route or port scans, I get rid of that after just 2 hours, and that's just arbitrary. But that is trimming. So again, that is a database function. Just like this, summarization is a database function purely. I take stuff from one table and put it into another table. The trimming is I'm basically just deleting old entries from the database. So both of these, and that's why I'm doing them together in this lesson, they're both database oriented. All right, now let's begin to discuss how I implemented it. And as with a lot of stuff that I've done and that we will do and you will do as you develop software, there's always multiple ways to implement stuff. So what I'm going to show you here, this is a slide that I made a while back when I was first doing this thing that I'm now calling Quokka Prime, and I was contrasting how I did things in Quokka. By the way, if you're new to this, you can go back, you can look at stuff where I've talked about Quokka. There is a repository called Quokka. That is my first implementation of the functionality that you see in the stuff that we've been looking at here. It's a little bit more, but it was my initial implementation. For the purposes of the 52 Weeks of Python class, I implemented things in a different, simpler way. Actually turned out to be that there were some advantages for distributing monitors and stuff of that nature. So I actually kind of like this way of doing it. But let's look at the difference, and you can kind of see from the picture. In this picture, inside my Flask application, I have my monitors running. I have device monitoring, compliance monitoring, host monitoring, service monitoring. Oh, and guess what? There's that thing called Summaries. That's also running inside there. Now, for 52 Weeks of Python, our Quokka Prime, what we did was we implemented host monitoring, device monitoring, service monitoring as separate applications because that was an easy way to do the teaching, and it kept everything separate, and you didn't have to understand all the nuances of maintaining multiple threads and managing them and things of that nature. So this made it a little bit easier. It made better use of our REST API. It may not have been as fast writing things to the database, but that was a trade-off we were willing to make. And we ended up, if you recall, we ended up speculating about distributing this throughout your network, so you have host monitors and device monitors and service monitors in every one of your, let's say, IP subnets or something of that nature. Anyway, it makes it more distributable. But the point is, inside Flask, what do we have running? Not a whole lot. In fact, you can tell this is an old slide if you're paying attention, which I wasn't. That's SQL Alchemy. We're not using SQL Alchemy anymore. We're using Mongo. So you can see this is an old slide. But don't let that distract you, because the point that I'm making is that there's none of these extra threads running in here. So my question would be, since I've taken all of these other things and run them as separate applications, should I do summaries in the same way? And should I create something over here called summaries? Now this would require that I go through the REST API and communicate and grab stuff from the database, summarize it, and then write it out. And I could certainly do that, but am I going to ever distribute that? I'm not going to distribute that. That's going to be something that's going to live with the database itself, and the database lives with Flask. So what I've decided to do, and I don't have a slide for you, so you're going to have to imagine it, and I'm going to show you the code, is I've taken and I've implemented summaries, a summaries thread that runs inside Flask. Now when I say summaries, I mean summaries and trimming. What I actually ended up doing after I created this slide was I had a DB maintenance task. That was my table trimming, and I've actually combined them into an hourly database task that is running inside Flask. So what we're going to see in our Flask application, in the Quokka server application itself, you're going to see that I'm going to be doing things like creating a thread that is going to then run, and every hour it's going to wake up, it's going to do the summarization, and it's going to be trimming of excess data. So that's the general idea. That is the code. You can see a little bit here in my database APIs. I have a function called trim tables, and I have a function called create summaries, and I'm actually running that within my Quokka server, so within this Flask thing that you see right there. So I have one of these that's running in here now, and that's what we'll look at next. Okay, so here we are inside Quokka server. Quokka server is the Flask application code that gets run. If you recall, when we say Flask app equals quokkaserver.py, this is what gets run when our application starts. Now, nothing here has changed. What we're going to be looking at is this primarily. This is going to be our DB hourly task. We're going to create a thread and we're going to start it. Just FYI, for doing a shutdown gracefully, I had to add this code. This is similar stuff to what I did in Quokka, and we'll talk about that. But the main thing is in this file, what did we have? We had endpoints, right? Here's my /hosts endpoint. Here's my /devices. I'm going to go down to the middle here. Here's my worker for getting port scans back. Here's my trace route requests, etc. And then if you recall from our last time together, we added a few endpoints called host status was one of them. Host status, service status was another, and then the last one would be device status. So now this is for when the user interface is going to come in and get the data. You might say, well, I bet you built some more APIs, and if you look down here, sure enough, there's nothing at the end of this. So what did we do for the summaries? Well, if you have an eagle eye, you may have noticed. Remember what this was. This right here used to just be open square brackets, close square brackets in last week's lesson, because I hadn't implemented it. In fact, here's a little cute thing. Remember, I've done this annotations in the gutter. If you look right here, you can see, oh, well, Chuck basically added some stuff here. In fact, it looks a little bit better here because I didn't mess around with this one. I messed around a little bit with this status one right there, but mainly I changed summary. You can see down here, I changed summary, and you can see down here, I changed summary so that it basically calls get status summary, and that is what is going to read the database and return the information that allows this stuff to get printed nicely in my user interface. So in this Quokka server, let me get rid of the annotations. In Quokka server, basically all I really needed to do, I didn't build new endpoints. I just added some stuff to replace the empty list with this actual data. Now the important thing that I did in this file was up at the top. And the most important of those important things is this part right here, starting the background thread. If you remember from our threading discussions, or if you have looked at the Quokka application, then you'll be familiar with what I'm doing here. And I'm not going to go through all the details of threading, but basically I have a class here. I'm going to do Control B to take me to that. Here's my DB hourly task. So I just have created a class. It is going to represent my task. So I'm going to create an object that is called DB hourly task that is created off of this DB hourly task class that we just looked at. Then I'm going to create a thread by using the threading library, and I'm going to say threading.thread. Now there's multiple ways to create threads. I could have inherited from thread in my DB hourly task. I'm not doing that. Instead, I'm doing the kind of more simpler way of doing it, the non-object oriented way of doing it. And I'm passing in this DB hourly task that I just created .start. That is going to be the name of the function that this thread will run. And you will expect there to be a start method in my class, and sure enough, there is. So basically, it's going to be running this. So this is a combination of classes and of, here I'm passing in a function, which is actually not a function. We would call it a method because it's inside of an object, but it's the same thing. And this is what's going to get run at that point in time. And then my thread hasn't started until I say DB hourly task thread.start. I do talk about this in our 52 weeks of Python, where I talk about threading, thread pools, and async IO, so you can look there for some other examples. But I will be looking at this code next. That is the main thing that I want us to see here. Next, we're going to dive down and look at actually what happens inside this DB hourly task function. Okay, so here we are in DB hourly task. Remember, from Quokka server, we created an object called DB hourly task. That's what we called it here. That is the class from which we got it. That's what we're looking at here. Now recall, when you instantiate an object from a class definition, what's going to happen is it is going to call the constructor. This is the word that we use in object-oriented programming, is constructor. And the kind of semi-kludgy thing that Python does to make that happen is it calls this special method name called underscore underscore init underscore underscore. So all you need to know is that when I create an object from this class, this code here is going to run. I'm only going to create one of these. What it's going to do, if you recall from our object-oriented stuff, it's going to set its own variable called terminate. That's going to live inside this object. It's going to set that to false so that I will continue to do that. That gives you a clue that probably the way that I'm going to kill this is that I'm going to set that to true, and that's correct. Now here's an important piece. I'm going to set the current hour. So whenever this gets created, I'm going to set my current hour, and as you can imagine, I will be updating that. Let's look at this a little bit just to understand this and make sure, for those of you that aren't Python experts or advanced or whatever, datetime.now is going to give me a date object, date time object, which represents this moment in time. Remember, this is right when it gets created, so it's at the very beginning of me running my Flask application. So this gets called once, but we will reset it over and over again. Now when I say give me the string related to that, because it's a date time object, it knows how to create a string from that. And just if you were to peek down here, you can see it's going to look something like this. All right, that's what the string is going to look like when I do that. But when I say current hour, I don't just want the number, and this is the kind of, I'm not sure I would say tricky, I might say intelligent, maybe other people would say tricky, but the way that I do this is I say, give me this string for right now, but I only want the first 13 characters. All right, this is a string. Remember what we call this? I'll give you a minute to think up the word in your mind. You can pause it if you can't remember it and you want to think about it, but this is called slicing. So this is taking a slice from a string, and it's saying I want the first 13 characters. As long as I have something handy here, I'm going to look at this. I can tell you the first 13 characters is going to be that thing right there. It's the year, it's the month, it's the day of the month, and it is the hour, and the hour is in 24-hour format. This allows me to do handy searches in the database and to only look for things that match the current hour. I don't care about the minutes or about the seconds. I can just deal with this portion of it, and it allows me to use simpler Python data structures and constructs. Those of you that are advanced, you may be saying, well, why aren't you using date time to store that? Because databases have special date time data types, and they can store it and you can do special things with it. All of that is 100% correct. In a real large project, as I've done in every situation in my past, I would be using that. But for simplicity and for teaching purposes, I'm just going to be using the string version of the time, and I will continue to do that. I may have a lesson on using times later on, but that's basically what I'm doing. I'm getting the current hour, okay? Are you with me there? Let's move on. Now, looking at the next thing, you can say, see, oh, I'll bet you he's going to say call set terminate, and all that's going to do is it's going to set terminate to true and print out this message that I'm gracefully exiting. Now, the reason that I need to set terminate to true, it's not going to terminate immediately, because this is basically what my thread is going to do. It's going to sit here and it's going to loop forever or until terminate is true. And what is it going to do? Here's the waiting code. Basically, it's going to get what is my current hour. Remember, the hour is not just 15 as you see down here, but the current hour is this entire thing. So this will only be true for 1 hour of all of our lifetimes, because we will increment the day, and we'll increment the month, and we'll increment the year, etc. So this is guaranteed to be unique. So if the current hour is what this hour is, then I'm just going to go to sleep. Now I'm sleeping for 15 seconds here. I could sleep for a minute. I could sleep for 5 minutes. I don't really care all that much. I could sleep for half an hour if I wanted to. But here's the thing. My while loop, I'm going to continue to sit in here and do this sleep. If I sleep for 30 minutes, then I'm not going to end up finding out that I need to terminate. So this number affects how long it takes for me to wait until the whole thing shuts down. Just to give you an idea, let me go back. Here's my Quokka Prime server. I'm going to hit Control C a couple times. You can see that there's a keyboard interrupt. It's waiting. Now the maximum it will wait is 15 seconds, and you can see I didn't even have to speed it up. It has exited. Okay, I'm going to set this back and let it run again. And you can see here, this is the code that I printed when I said I started my task. So now that is back and running. All right, let's look at what this code does. And there's really only two pieces that you need to care about in here. One of them is this. I'm going to trim the tables. That is getting rid of old data. And as you can kind of get that hint by seeing that the two parameters that I'm passing in, one is expire after for status tables. One is expire after for diagnostic tables. And you can see, as I said, I hard-coded them. You may want to do something more intelligent in your own situation where you are passing that in as a parameter or something, or maybe you're satisfied with this if you want to keep it simple. Basically, one thing I'm doing is I'm calling in trim tables. We'll look at that in a bit. The second thing I'm doing is I'm doing create summaries. So I get down here when it's the next hour, right? So basically, I didn't actually go over this, but if it's the same hour, I continue. I just go back up here, wait 15 seconds, wait 15 seconds. And then when finally the hour is the next hour, basically, when it's the next hour, I'm going to come down and I'm going to do my trim tables, and I'm going to do my create summaries. And then when I'm done with that, I set the current hour to this hour so that my current hour is now the next hour. And then I go back and I sit here again. So basically I sit in this forever until I get told to terminate. And the important stuff, the interesting stuff is right here in trim tables and create summaries. That's what we're going to look at next. All right, let's look at the code for trim tables. When I dive down into it, it's in DB APIs because this is really a database operation. And I have my expire after for both status and diagnostics. Now let's look at this first one. The first thing to notice is that I have this for loop here. Now the reason that I did a for loop is I realized that basically this fundamental statement that I'll explain in a minute is going to be exactly the same whether I'm doing host status, services status, or devices status. This is something I really like in Python, and that is that I can just create a list right in the middle here, and I can have as my list db.hostStatus. Remember, everything in Python is an object, so this is just a reference to my database table, and this is a reference to the services status database table, and this is a reference to my devices database table. That means I can then say status table, and the first time through it will be doing db.hostStatus. The second time it will be db.serviceStatus, etc. So that is really handy. Of course, I could have done these individually and just said db, have a statement that says db.hostStatus.delete many and the rest of this, and then done the same thing for db.servicesStatus. But just, as you go through and you begin to recognize code that you're repeating, then doing a for loop like this begins to make sense and it becomes second nature. So that's the for loop. Now let's look at the database statement in my Mongo database using PyMongo. Basically, if I want to do a deletion of many items, then I use this method called delete many. And let's look at what I'm passing to this method. You'll remember that in my database stuff, I have a lot of things that I am doing things to the database, like I'm doing finds of searches, I'm doing sorts, and quite often what I end up doing is I end up passing in a dictionary, and that's what I'm doing right here. You can see my dictionary. The key in the dictionary is time. That's going to be referring to as you can peek down here, I don't want to highlight it, otherwise I'll lose I'll lose my focus. But you can see this is a field in my database called time, and the actual value is itself a dictionary. And this dictionary item, let's look at this at a high level first. If I just look at this without knowing any details, I would say, well, that looks like you're doing special. That's a less than. So that is indeed what I'm doing. I'm saying I want time to be less than, and then I'm taking my expire after and making that a string. I actually don't know. Is my expire after? It may already be a string. I don't know. I'm not going to look back and see if it's a string already. But you get the idea. I want to expire after. And what am I doing? This is going to be basically an hour. It's going to be something like the first part of this because I'm running this hourly. And so why can I do less than? I can do less than because it's just a string lexicographical comparison of these things. And if the number is less than, then I'm going to delete it. And as you can see, this is always going to be incrementing, whether I'm incrementing the hour or the day or the month or the year. So it's getting rid of everything that is before that. This is I guess you could call it a trick, but it is a nuance of the way that strings work because of the way that I've done these strings. Now, if your time string said something like June 14th, 2021 at 3 o'clock p.m., of course that's not going to work. So I need to have, and I'm going to click on it, I need to have it in this exact format in order for me to do this cute way of doing a less than. Hopefully that makes sense. I know you got a lot of dictionary stuff going on, but that is the Mongo syntax, and this is the way I specify that I want to do a less than. You can imagine there's a greater than. I suspect there's an equals. You can just look that up and figure it out yourself. Now that we've described what we're doing for status tables, you can see that for diagnostic tables, it's exactly the same thing, except look at the difference. Here I'm doing status expire after. That's going to be my 24 hours. And here I'm doing my expire after time, which was set to be 2 hours from the current time. So yeah, this is an actual full date that is 24 hours ago. This is an actual full date and time that is 2 hours ago. And that is how we trim the tables. Pretty simple, huh? Okay, we just talked about trim tables. Now we're going to talk about create summaries. And remember how I said trim tables was really pretty easy and we looked at it? Create summaries technically is pretty easy when you think about all that we're doing, but there is a fair amount of code here. So I did want to warn you about that to begin with. Here is my code for creating summaries, and I'm going to make this as big as possible so that we can see most of this function. It really ends just about there. So a lot of this code that you're going to see, in fact, all of this stuff right to here is setting things up. I'm not really doing anything other than creating this list of status table information. This is status table information, each one of these. There's 3 of them. As you can imagine, they are directly related to each of the different database tables. I'm going to have one of my status table infos is going to be about host status. The second one, services status. The third one is device status. Now, what do we need to have in my information for each one? Well, there's 4 things. One is I need the names of all of the items. So what I'm doing is I'm going to be calculating the summaries for every host individually. So I'm going to have to do multiple passes, one for each host that exists in our database. And that's why I need to know the host names and the service names and the device names for them. The search field, you'll notice, and this is a problem, I probably should have named it something different, But if I had named my host name in my host database, if I'd given it the name just name, then it would have matched what I had in services and devices. But I didn't. I have name and name for services and devices because it's a host name. I called it host name and host, but it came up to bite me a little bit in the butt. So I need to specify what is the search field. Now I need to specify two important things. One is what is the status table and what is the associated summary table. So Mongo doesn't know that host status goes with host status summary. I know that. The code certainly doesn't know that until I make the code behave appropriately. So I need to have that. So that's what this is. The stuff in front of it, this is just making sure that I don't have to retype search field and I might do a typo. Remember, this is keeping me, allowing me to have a constant, which Python isn't really great about, but this is one way to do constants so that I don't have to keep typing and potentially do a typo. And then this, I'll let you gnaw on this one, but this is basically me getting all the host names. So in fact, let me look at one of these. So remember, what is this called? It's called a list comprehension. Let's look here. This is my for loop. So I'm saying for host name in. Now this has to be iterable. And what is it? This is kind of complicated, so hang on here. This is going to be effectively like a list. I'm going through the hosts table. Notice I'm not going through host status summary. I'm going through the hosts table and I'm finding every host. So every host will be unique. My search criteria is empty. That means I'm getting every single one. And now if you recall, I think I went through this in one of the classes a week or two ago. In PyMongo, what I can do in my find statement, first I specify what is my search criteria. It's nothing, this, which means I get everything. The second is, what do I want returned? And here I'm saying, I want you to return the host name, basically saying this is the field, host name, and then 1 is just a numerical true that tells PyMongo that we want to return the host name. Everything else will not be returned except for the underscore ID, which we don't care about in this situation. So here's my loop. I'm going to go through the host table and I'm going to get every host name. And for every host name, what am I going to do? What's the thing that's going to go into the list? The thing that's going to go into the list is the host name. And I just realized I probably named this wrong. Now that I think about it, I should say for host, this would be more appropriate if I were to say this. So there, I've changed it on the fly to make it more readable. I'll make the rest of these changes later. And I probably don't even need to specify this now that I think about it, because I'm going to extract host name anyway. So I could do this. This is a simpler way to do it. And I will make these changes later. Of course, I haven't tested it to make sure it works. Probably before I before I publish this, I better make sure that it works the way that it's supposed to work. But this is a much simpler way of doing it. This is giving me the host names. And then I will do the same thing here. It will give me the service names. Once I've done that, what am I going to do? I'm going to go through all the status tables. What are status tables? That's these things that I just defined. So I'm going to go through this, and every one of these, the first time through, status table info is going to be this stuff right here. And now I'm going to go, because I want to keep it a little bit clean, I'm going to say generate status for hour, and I'm going to pass in these 4 things. I could have passed them in as just status table info and extracted them, but I chose to do them explicitly using this. And the last thing I'm passing in is the hour. And remember, the hour is going to be that entire portion of the string up to the hour. So let's look at generate status data for hour and figure out what this does. Now this I'm going to go through pretty quickly, so you can go into this in more detail. You probably know mentally what I'm going to be doing. I'm going to get all of the status data items for an hour, and I'm going to take and add all the availability, then divide it by the number of availability records. I'm going to add together all of the response times, and then at the end I'm going to divide by the number of response time records, and I'm putting that in this thing I'm calling hourly summary, and I'm writing this into the hourly summary table. Remember, my summary table is going to be either db.host status summary or services status summary or devices status summary, but I'm reusing this code for all of those. And there's a bunch of extra stuff. Here's hourly summary. This is the piece of data that's going to get written. I created, it's a dictionary. I'm going to put the name in, so it will say host name or name, and it will be the actual name that I got passed in. Remember, I'm going through all of the names. So I'm going to go through the table and get the records for that hour, and we'll look at this in just a second, for a particular name. And then I'm going to go through here and do this for loop, which is going to calculate things. And remember, you need to only be adding this together if availability was true. If availability is not true, then we just don't add 100. But the important thing, or the thing that you could have errors on, and I know I worked on a product that did this back in 2000, a long time ago. This product made millions of dollars, but right before we were going to release, we realized that we were calculating the response time wrong, because we were calculating in a 0 for the few times when availability was unavailable. And so you want to make sure you only add response time appropriately. That's why we keep a separate count of response time records. And availability records, every record is an availability record because it will be true or false. And this is the calculation that we do. Last thing right here I want to put, and that is this, or I want to talk about, how am I getting the data to do this calculation? Well, I'm going to call it status items for the hour. So I'm going to go from the host or device or services status table. I'm going to go and I'm going to get items for that particular name. So I'm going through all the names one at a time. And then here's my time. And this time what I'm doing is I'm actually doing a regular expression. Why am I doing a regular expression? Because I want to match on this caret right here, which says I want to only match when the time starts with and then my hour. Now this makes it easier and much faster for the database to do it if it can do the comparison from the beginning of the string. If it was having to do it and compare all characters of the string, of course, that would be worse. That's why we're doing the regular expression. If I was lazy, I could have just said time and then put hour in there, and that would have worked, but it would have been slow. It would have been not very optimal, and people would not have thought that you were a good software developer if you had done that, because you know that we're matching it from the beginning only. So that is what generates status data for hour is, and I go through and I do that for all 3 of my status tables. If I add another status table, which I've done in the past, I've done status tables for workers. I suspect I could do it for monitors and other things as well. Then I could just add those here, and it would work in much the same way. Hopefully that makes sense. Sorry, it's a lot of stuff, but I'm hoping that it made sense to you and that you now understand how we create the summaries. The summaries, of course, allow us to do cool things like response time and availability summary. One last thing I didn't go over, and it's appropriate that I handle it at the end, and that is this thing right here. This is the code that allows me, when I come in and do a Control-C here like I did, it allows me to terminate my thread. And so basically what I say here is I say add exit. This is something that we can import from Python. And I say add exit. I want to register this function, the function called shutdown. And so what's going to happen is when we're exiting for some reason, we will call shutdown. Shutdown is going to take my DB hourly task and do a set terminate. And the next thing it's going to do is it's going to do a join. If you recall from our threading code and discussion, when we do threads individually and not using a thread pool, then we need to do a join. And while that is kind of a weird word to use, that is what we use for certain things in Python, and that's what we use for threading. So join basically says wait until the thread ends. And once it is done, then we exit and exit gracefully. All right, who remembers what we talked about in this lesson? Probably nobody. But if you did remember, or you do remember, give yourself a gold star. That's very impressive. We talked about two things. One is trimming data once it's old and we don't need it anymore. The second thing that we talked about was generating summary data. This would be hourly summaries, and how are we going to do that? We talked about this slide and how in the previous version of what I did for Quokka is I implemented everything as a thread. All of my monitors were implemented as threads, including summarization and trimming. And now with our new model, that's the 52 weeks of Python model, we have these things external as individual autonomous applications, and that's cool. But we said summaries, that really belongs with the server and with the database. So we're going to have to create threads in order to do that. We looked at the code and we saw that in our code, this is what we needed to do in order to create our thread that's going to be running in the background. And I call it an hourly task because basically it's going to sleep for the hour and then it's going to wake up and it's going to do summarization and it is going to do trimming. And if we look at this, here's my hourly task. Terminate is what's going to tell me I need to end current hour. I always need to know what my current hour is. Remember object-oriented stuff. Self means my object is going to keep track of this so that data doesn't go away. My loop basically comes through here, and if it's not time to wake up yet, we sleep for 15 more seconds. When it is time to wake up, we call trim tables, and then we call create summaries. Trim tables was actually pretty easy when we look at it in a grand scheme compared to summarization. All we do is we iterate through these tables and we do this clever database search and find things that have a date that's older than the expiration date, and we're going to delete them. And we do that for diagnostics and status tables. Creating summaries involved a little bit more stuff. A lot of it was prep work. In fact, all of this was preparation for getting the status table info ready so that I could then iterate through these, not having to repeat the code over and over and over again. And I call generate status data for hour. In here, I go through my items, I do a find, and I'm searching for the particular name that I'm looking for, and I'm looking for the time for that specific hour. And once I have those, I come through and iterate through all of those status items, and I add availability stuff together, and I add response time. And at the end, I calculate those values, and then I insert it into the status summary table. And this works. This code right here works for every different type of status table that we're throwing at it, as long as it has a time field and availability and response time. So that's what we talked about. Hopefully that made sense. If not, as always, give me a shout in whatever means you feel suits you best. And thanks for watching.